All right, guys, let's start section 3. And section 3 is all about rotations. So when we talk about rotations, there's a couple things to note. One of them is that unless specified otherwise, so I'm going to write this up here. So unless specified otherwise, our standard rotation, I'm just going to abbreviate STD, rotation is counterclockwise. Okay, so for those of you who don't know, counterclockwise is this way. Okay, that might be opposite from what you would think, but that's how it is. And we rotate about a point. So like when we reflect over an entire line. When we rotate, we just rotate around a point. So like if you look at this visual below, we're rotating this counterclockwise 40 degrees. So from Q to Q prime, we're rotating 40 degrees. So this angle right here is 40 degrees. Okay, we're rotating R to R prime. This angle is 40 degrees. So every single point is rotated around the center of rotation the same amount of degrees. All right, so let's define what a rotation is now. So a rotation is a transformation which rotates a geometric figure counterclockwise about, and apparently I can't spell about a fixed point. Okay, and when I say fixed point, I mean it doesn't move. Okay, it stays there. Okay, the center of rotation, like we just shown here, the center of rotation would be right here. It's the point that everything's rotated about. So the fixed point, and once again, it doesn't move. The fixed point in which all rotational transformation is rotated around. And the angle of rotation is the measure of the angle in which a figure is rotated counterclockwise about a fixed point. And if you don't know what counterclockwise is, you might want to do this way. So if you think about a clock, 1, 3, 6, 9, I guess this is a 12, not a 1. We go this way, right? We go from 1 to 2 to 3 to 4 to 5. So this would be clockwise. This is counterclockwise. All right, like reflections, we do have some rules. And these rules are all around when the center of rotation is at the origin. Okay, and 99% of the time, that's where it's going to be in this class. So when the center of rotation is at the origin, so we're going to rotate it about the origin so many degrees. So we have a rule when we rotate it 90 degrees. We have a rule when we rotate it 180 degrees. And we also have a rule when we rotate it 270 degrees. Okay, so these are just like reflection rules. We read them the same way. So this is also something you need to know and memorize. So please do that. And once again, this is when we rotate it counterclockwise. Okay. All right, so let's do example 1 now. So the first thing that I'm going to do is I'm going to plot RSTU. So go ahead and plot RSTU, and then we'll worry about the rest here in a minute. All right, so I went and plotted my RSTU, and it looks something like this. And this is a me thing, but it always helps me to write the points here, especially if I'm going to be using the rule. All right, so we want to rotate it 270 degrees. And because it doesn't tell us otherwise, we're going to be doing 270 degrees counterclockwise. Okay, if it wanted us to move it clockwise, it would say move this image or rotate this image clockwise 270. But since it says nothing, it implies that it wants us to go counterclockwise. So if we look at these rules right here, I'm just going to write, go straight from these rules, 270. Okay, AB goes to B negative A. Okay, so I'm going to write this here. So I'm going to say AB goes to B negative A. Okay, and from there, I'm going to find the points of my R prime, my S prime, ooh, my R prime, come on, my R prime, my S prime, my T prime, and my U prime. Okay, so notice what's first is now my second coordinate here, okay? So my A goes to a B, and my B's here. So the first coordinate of each one of these, all I'm going to do is I'm going to take this B. Remember, this is A, this is B. Okay, I'm going to take this B here. So first coordinate of R prime would be 1. First coordinate of S prime would be 1. First coordinate of T prime would be negative 3. First coordinate of my U prime is negative 1. Okay, so that takes care of the first coordinate. And then notice my second coordinate is negative A. Okay, so here's my A. So all I'm going to do is I'm going to make each one of these a negative, and that goes second. Okay, so my 3 becomes a negative 3. My 5 becomes a negative 5. My 5 becomes a negative 5. And my 2 becomes a negative 2. Okay, and now that I have my coordinates of my R prime, S prime, T prime, U prime, all I have to do is plot it. So after you plot the points and then connect them, it should look something like this. Now I want you to notice that from our original to this, they are congruent figures. They've just been kind of misplaced and they've been turned, but the shape of them doesn't change. All right, let's look at example 2. Now, I always start these the same, and you may not have to, but it helps me. I write AB, which is negative 4, 4, and negative 1, 7. Okay, now notice I'm doing two things to it. So I'm going to have an A prime and a B prime. And then I'm also going to have an A double prime and a B double prime. And I know that because here's my A prime, B prime. Here's my A double prime, B double prime. So the first thing I'm going to do is I'm going to plot my points A, B. All right, so I've plotted my A and B. So now I'm going to find my A prime and my B prime. Okay, so my A prime, first I'm doing a translation. So this tells me I'm moving left 2 and down 1. So I'm going to go left 2 from negative 4 is negative 6. Down 1 from 4 is 3. And left 2 from negative 1 is negative 3, and down 1 from 7 is 6. So here's my new coordinates of my A prime, B prime, and I'm going to go over and I am going to plot them. All right, so when I plot that, I should have something that looks like this. Now, it's always good visual to double check to make sure they look like they're the same size, the same shape, and all that, because if they're not, you need to double check your plots, because otherwise the third one's going to be wrong if you don't have the second one correct. All right, so now I'm going to rotate it 90 degrees about the origin. Okay, so when I go 90 degrees about the origin, if I go back to my rules, I would see that the rule is AB goes to 90 degrees, it goes to negative B, comma A. Okay, so I'm going to take the opposite of B, so I'm going to change the sign of B first, and then my A stays the same. Okay, but it's just going to go second instead of first the second time around. So my negative B here would be a negative 3. My negative B here would be a negative 6. Okay, and I'm going to keep my A for my second term. So it stays negative 6, and it stays negative 3. So now all I'm going to do is I'm going to plot these points. All right, when you plot the points, it looks like this. I know this kind of looks awkward for some of you, so I'm going to kind of draw in or try to show you a little bit. So we rotated B prime and A prime to B double prime and A double prime. So that means, and we rotated around the origin, remember. Okay, so that means if I were to connect, and I'm just going to do dotted lines from A to A double prime, remember, this would be 90 degrees. okay? And if I would connect my B to the point I'm rotating around to my B double prime, this here is also 90 degrees, okay? So hopefully that makes it a little easier for you to see. All right, I want you to go ahead and try to do example 3 on your own, and then we'll go over it. All right, so this is what you should have gotten. Okay, so my green is my TUV, which goes to my blue, which is my T prime, U prime, V prime. And then remember, we're putting the third operation according to the second one. So we're starting with the second one. We don't go back to the first. And so from here, we go to here. So what's in red would be my final thing. So when I did my rotation of 180 degrees, guys, all I did is I took that rule. Okay, and I just made both of these negative. So it's the same numbers, just both are negative. And remember, I know we didn't have an example of this, but if both of these were negative, then both of these would be positive. Okay, we just changed the sign. All right, so after I rotate at 180, I get to my blue, and then I reflect it over the x-axis. So I just went and I looked at my rule from that which we learned yesterday, and all I do when I reflect it over my x-axis is I just change the sign of my second coordinate. Okay, so right here, my second coordinate is negative, so here it's a positive. My second coordinate is negative, so here it's a positive. Here it's a positive. Okay, so that's all I did. So your final answer should be what's right here in red. All right, so now we're going to talk about rotational symmetry, and then after this we'll be done with this section. So rotational symmetry is, can we rotate a figure so many degrees to where every point will lie on itself? Okay, so our center of rotation is going to be in the center of these. Okay. So if we rotate this 90 degrees, it would look kind of like, I don't know, this point would be way over here. So that would be a no. If we rotated it 180 degrees, this point would now lie here. This point would now lie here, and so on and so forth. So this would have 180 degree rotational symmetry. Okay. If we do this stop sign, guys, so if we rotate this 90 degrees, this here would be right here. So it'd be 90. And if we rotated another 90 degrees, so 180, it would be right there. And if we rotated another 90 degrees, it'd be right here, so 270. Okay, well, you might think we're done. Well, actually, if we didn't go all the way to 90, say we went half to 90, at 45 would be here. If we went 135, it'd be here. And if we went, what is that, 215, I think, would be there. And then 270 plus 45, that'd be 315. So this would be 225, sorry guys, and then 315 would be here. So that one has a ton of them. Okay, so for these next 4, I want you to find the rotational symmetry if you have it. Okay, not all of them have them, so go ahead and do it on your own and then we'll go over them. All right, so if you go through these, this is what you should get.